Dear children, welcome to this session on Chapter 13, Introduction to Object-Oriented Programming. Procedural programming, modular programming, object-oriented programming. These are some of the programming paradigms. Paradigm means organizing principle of a program. It is an approach to programming. There are different approaches to solving a problem. A software developer or programmer may choose any one of these approaches. Each of these programming techniques are based on certain principles. The principle on which a program or software is built on is called as paradigm. Procedural programming emphasizes more on procedures. A procedure is a list of instructions given to the computer to perform a specific task. The following are the features of procedural programming. Programs are organized in the form of subroutines or subprograms. All data items are global. When data items are global, they are common to all the subroutines of a program. Since data items are global, any change in data type of a data item need to be propagated in all the subroutines that use that data item, which is time consuming. That is, if you want to make any change in a data item, you have to make changes in all the subroutines that use that data item. This is a disadvantage in procedural programming. Procedural programming is suitable for small-sized software applications only. The programming languages which are based on procedural programming methodology are Fortran and COBOL. Fortran stands for Formula Translation. COBOL means Common Business-Oriented Language. In modular programming, a set of related functions are grouped together into independent parts called modules. The following are the features of modular programming. Modular programming emphasizes on algorithm rather than data. Programs are divided into individual modules. Modules are independent of each other and have their own local data. Modules can work with its own data as well as with the data passed to it. Examples of languages that follow modular programming methodology are Pascal and C. In your textbook, C language is said to follow modular programming. But actually, C language is based more on procedural and structured programming paradigms. Therefore, C language is a general purpose multi-paradigm programming language. The third programming paradigm and the topic of this session is object-oriented programming. First, you must understand the concept of object in object-oriented programming. What is an object? An object is a thing from the real world. It could be a house, a truck, or a bird. But an object need not be always something physical. It could be a schedule or a reservation for the cinema. An object is anything of interest to the software application that you are building. Suppose you are developing a software for your school, then student or a teacher could be an object. Therefore, an object is anything that you want to store and process data about. Another name for an object is an entity. Consider a box as an object. I define variables L1, B1 and H1 to represent the length, breadth and height of this box. My intention is to find the volume of this box. These variables L1, B1 and H1 hold the data needed to find its volume. These variables are called attributes. The volume of this box is calculated by the formula V1 is equal to L1 into B1 into H1. I can also write a function called the volume to calculate its volume. Now I have 3 variables and 1 function associated with this object box. I write a C++ program in the usual way to find the volume of a box. The variables L1, B1 and H1 are defined in main function. They represent the data of a box. And the volume function calculates its volume. In this program, you can see that the data and function reside as separate entities as in procedural programming. But the aim of object-oriented programming is to create an object that groups together data and functions into a single entity. Therefore, an object is a data structure that encapsulates data and functions into a single entity. Encapsulate means to bind together, to enclose in, as of in a capsule. One of the basic principles of object-oriented programming is encapsulation. The term encapsulation is derived from the word encapsulate. Hence, encapsulation is the process of binding data and functions together. Hence, we can conclude that object is the basic unit of object-oriented programming. The following are some of the features of object-oriented programming. Object-oriented programming emphasizes on data rather than algorithm. Data abstraction is introduced in addition to procedural abstraction. Data and its associated operations are grouped together into single unit. Relationships can be created between similar yet distinct data types. Java, C++, and Python are programming languages that are based on object-oriented programming paradigm. Here I have 3 boxes B1, B2, and B3. These boxes are similar yet distinct. Similar because they have same attributes, length, breadth, and height. Distinct because each of them have different values for length, breadth, and height. And their volumes are calculated using the volume function. If I had to work with only one object B1, I had to define only 3 variables L1, B1, H1. But with more number of similar objects, more number of variables need to be handled. This makes programming difficult. In order to simplify things, I can create one object called box, which has 3 attributes, length, breadth, and height, and a function volume to calculate its volume. This leads us to another important principle of object-oriented programming, namely abstraction. Abstraction means simplifying things. This common object box serves as a template for all the boxes. We can now think of this template as a blueprint from which other objects are created. Since all these objects are created from this template, these objects have the same attributes of this template, that is length, breadth, and height, so that now I can get rid of all these variables. From this, it must be clear to you that abstraction simplifies things. It helps us to reduce the number of variables needed in a program. In programming, this template is created using a data structure called class. Therefore, class is a template for the object. An object is an instance of the class. Class is also a user-defined data type. A user-defined data type is a new data type created by the programmer himself by combining primitive or built-in data types. Look at the classification of data types in C++. Data types are classified into user-defined type, built-in type, and derived type. And class comes under user-defined type. Therefore, class is a user-defined data type. Object-oriented programming encourages modularization and software reuse. Modularization is the process of decomposing the program into modules. Software reuse means composing a program from existing and new modules. The main features of object-oriented programming are abstraction, encapsulation, modularity, inheritance, polymorphism. Abstraction is the process of ignoring or hiding irrelevant details and modeling a problem only by its essential features. To find the volume of this object box, it is enough to know its length, breadth, and height. Other details such as the material with which this box is made of or its color is not essential to the problem. Encapsulation. Encapsulation is the process of binding data and functions into a single entity. When data and functions which are separate are bound together into a single unit, this process is called encapsulation. Encapsulation provides data hiding and data security. Modularity. Modularity is designing a system that is divided into functional units called modules. A complex problem is decomposed into modules, and these modules are once again put together to get the solution to the complex problem. Inheritance. Inheritance is the process of creating new classes from an existing class. I will explain the concept of inheritance with an example. Suppose I have a template for the object person, defined as class person. And then I want to create a new template for a student object as class student. But student is also a person because a student also has ID number, name, gender, and date of birth. So instead of defining these attributes once again in class student, I only focus on the additional attributes required for a student such as course, year, and section. And then when I create inheritance from class person to class student automatically acquires all the attributes of class person. By inheritance, class student can access all the properties of class person. That is, class student has attributes ID number, name, gender, date of birth, in addition to its own attributes course, year, and section. Therefore, by inheritance, we can avoid unnecessary repetition of attributes. In the same way, to create a new template for a teacher object, and since a teacher is also a person who has ID number, name, gender, and date of birth, I just perform inheritance from class person to class teacher, and then I define only the additional attributes needed for a teacher, such as qualification, subject, and classes. Inheritance is the process of creating new classes from an existing class. The existing class is called as base class, and the classes created from the base class are called as derived classes. Since the properties of the base class can be accessed by the derived class, inheritance provides reusability of code. The next feature of object-oriented programming is polymorphism. Polymorphism is the ability of a message or function to be displayed in more than one form. Suppose I define a function called area in such a way that when I give the input as radius, it gives area of circle as the result. To the same function, when I give the inputs of length and breadth, it gives the area of rectangle. Therefore, this function area behaves in different ways depending on the inputs. Polymorphism. Poly means many, morph means shapes or forms. Using the principle of polymorphism, we can create a function or an operator to behave differently for different inputs. The advantages of object-oriented programming are as follows. Reusability. Write once and use it multiple times. Redundancy. Redundancy means repetition of information or data. Actually, object-oriented programming reduces redundancy. By inheritance, you can reduce redundancy. Easy maintenance. New objects can be created with small differences to existing ones. Security. Data hiding and data abstraction provide security to data. The following are the disadvantages of object-oriented programming. Size. Object-oriented programs are much larger than other programs. Effort. Object-oriented programs require a lot of effort to create. Speed. Object-oriented programs are slower than other programs because of their size. With this, I come to an end of this session. I hope you understood the concept of object-oriented programming. Thank you, children.